Hey guys, good morning. My name is Pawan Reddy, and I'm going to be your instructor for this course. All right. So before we start this, this Kafka requirement, right? Let's quickly understand ourselves, right? So what I want from you guys is your name, number of years of experience, and what technology you've been working all these years. I just want everything in a single line. So your name, number of years of experience, and what technology you've been working all these years. And if you're a fresher, you can specify fresher, and I got trained in Java or Springboard or something like that.
I'll get started. This is Jivika. I've been working on Java stack with the Node.js, Redis, Kafka, Spring, Hibernate, and I have overall 14 years of experience. And this session is also being recorded for my team, where we have developers with experience. Many are freshers, and then we have 1 or 2 years experience who've been working with Node.js, mainly Node.js. Angular and Java.
Okay. Right. So that's it. Okay. So yeah, I got an overall picture. Great. So let me talk about myself. My name is Pawan Reddy, and I got 16 years of experience, and I'm currently working as a solution architect. And I'm mostly into all big data platform. All right. And I've started my career as a Java developer, and from past 12 years, I'm into this big data technologies. All right, and let's start today's session. All right, so the agenda of today's classes, we're going to learn about Kafka internals, Kafka architecture, and we're going to learn about Kafka configurations. What are important configuration which is required for productions? All right, how to specify those configuration later, but in our next class, we're going to understand like how we're going to configure those properties in our Java and Node.js application clients. Right. So now let's understand what is Kafka. All right. So Kafka is a messaging system. Basically, Kafka is one of the scalable distributed solution for messaging. All right. And it follows PubSub model. So basically, PubSub model is nothing but publish and subscribe model I'm going to use. Now you need to understand quickly like why it is required. All right. So who created this and why it is required in order to understand this architecture. So let's understand this first. So LinkedIn is the one who has given this technology. So they got the requirement. So they got some problem, right? When they are creating data pipelines, and they have come up with some solution. So let's understand what is that problem. So in any production environment, you got like your source system. So basically, source system are the system which is kind of like serving your real-time users. Right. So let's imagine that this is nothing but my real-time system. All right.
Pawan, are you sharing screen?
Oh, all right. Hope everybody able to see my screen.
Yeah. No.
Okay, super. So basically, Kafka is one of the messaging system, right? We are trying to understand, right, how we got Kafka, all right, and then we're going to jump it into Kafka architecture. So we got like, all right, tons of real system in any production environment. So LinkedIn got like too many real systems, all right? For example, RDBMS, all right, they got kind of like some NoSQL databases like Voldemort, right? They got some kind of like application, which is kind of like producing some data. They got some internal application, which is producing the data. They got some security software, which is internally producing some data. So basically, I'm going to mark this as an X system, Y system, and there are so many other systems which is kind of like, all right, in the in the real world, it is kind of like serving your client, all right? So this sort of system, I'm going to consider them, and I'm going to use a name called real systems. Now, guys, if I want to make processing out of it, right? So what kind of like systems I needed? What are the processing options I have? Guys, I want everybody to interact. So I may ask a lot of small questions. You just need to answer in the chat box. All right. You don't need to open the mic and tell. You can use the chat box. So if I ask you a simple question, what are the different offline processing you have? What could be the answers? Quickly. So basically, these are nothing but my real system. And if I want to process my data historically or anytime if I want to process it, what are the solutions I have, right? If you observe, one of the solution is Hadoop. All right, one of the solution is Hadoop, all right, where I can kind of like store all this bulk data, and I can do the historical data processing. All right, you got your traditional ETLs, guys. You got your traditional ETLs. All right. So Informatica data stage, I can grab my data from this real system and I can process my data over here in this ETL, right? I got many other options as well, all right? So for example, let's say that I want to do a reporting kind of stuff. So this is nothing but my reporting server. So if I want to report, guys, again, what I have to do, I need to connect to all the system to collect my data across my reporting server, and then I can make a reporting out of it? Absolutely. So, so these are kind of like XYZ systems I have, all right? And I'm gonna consider this as nothing but my offline system. So I'm making some kind of like batch processing or real-time processing by collecting those data over here across this system, all right? So now the challenge, what LinkedIn got, right? Suppose if Hadoop wants to process the data, what they need to do here is, they have to collect the data from RDBMS, right? So basically, if I want to make a historical data processing, I may require to connect with multiple real systems to grab the data, day-to-day data in a real time, all right? And you can see that I've made almost like 4 connections with the real system, and I'm grabbing my data across my Hadoop, and I'm processing my data over here. I'm processing my data over here historically. Now, let's say that I got like one ETL system, I got one ETL team available. All right, they want to process your data in data state. Again, this data state guy required to have like all those information. Let's say that he requires to connect to Voldemort XYZ system, all right, all those systems. Now the reporting guy does have the same requirement. Reporting guy does got the same requirement. Again, it has to connect with all this source system, and he has to grab the data so that he can make some analysis. All right. Now, if you observe, guys, how your data pipeline looks now, does it look clumsy? All right. Does it become very complicated? Absolutely. All right. So it becomes very complicated, guys. And if you observe, there are downsides. All right. If you observe, guys, you are kind of like making n number of connections with your real system, which is actually serving your client back. All right. So you're hampering the performance, you're utilizing the IOs of RDBMS. Instead of doing their regular work, you are kind of like disturbing this real system to grab your data across here. So I'm making kind of like multiple connections with my real system that it's going to be hampered, and multiple times I'm performing IO operation to copy my data across like various systems. All right. So this is the challenge they got it when they are trying to build a data pipeline. So data pipeline is nothing but, all right, getting your data from one system to another system, all right, is nothing but you can call it as data pipeline. So these are the challenge they got it. Now, what is the solution they got it? And let's see. Now I got the same source system. RDBMS. I got some NoSQL databases. I got some XYZ system. So these are my real system, real production system, whatever system, real application, which is generating a data and all. Right. On other hand, guys, I got my offline system as usual. So instead of making multiple connection and hampering my real-time systems, right, I am going to have a layer now. And the layer name is Kafka. So Kafka is another cluster altogether. So what we are doing here is we are keeping another cluster in between these two, all right, source and destination, you can say. And we can have multiple computers, all right? So in this Kafka cluster, it is distributed in nature. If I say distributed, means not one single file system. I may have kind of like multiple file system. So if I say distributed, again, guys, all this advantage, I'm gonna get it. If I have 100 computers altogether, so I'm gonna get, with the help of this distributed file system software, I'm gonna get the resources of entire computer. So basically, if you use distributed file system, everything looks like a single computer, all right? And in that single computer, you're gonna get a distributed RAM. Overall RAM, you're gonna get it. Distributed storage, I'm gonna get it. Distributed IOs, I'm gonna get overall. So that is the power of distributed file system. We don't want to talk on this. There are bunch of advantages stuff you're gonna get it if I use distributed file system. Now, let's understand. I got, all right, Kafka in between, and I got like multiple system inside. Right. Now, if I want to use Kafka terminology, so early, all right, I can call this Kafka any computer. I can call this as brokers. So if you see how many brokers are there here? How many brokers are here? All right, you can see all, right? There are 4 brokers over here, right? So basically, these are the system inside my Kafka. We're gonna talk more on this, but at this point of time, let's understand how Kafka solve this data pipeline issue, which we have seen on hand before. So Kafka, right? So imagine that this is kind of like real user, all right? He is kind of like making some requests and I'm getting kind of like some kind of like data. So basically, this particular system is kind of like producing. So imagine that this guy is nothing but a producer, all right? So basically, producer is nothing but one who is kind of like producing the message. Or on other word, I can say, if this guy is producer or a real system, or this guy is kind of like publishing the message. All right, this guy is publishing the message. So this system is holding my actual data, all right, which I want to take it. Now, what they are doing, instead of kind of like every time any system get like wants this particular data, all right, they are not connecting to this real system directly. So we got a Kafka in between. So basically, whatever the real data is there, what I'm going to do here is in my Kafka broker, I can save that particular data. So if I want to save any categorical data, let's say that if I say categorical data, let's say that I got a login related information, I got an error related information. So I can store those categorical data by creating a category kind of stuff. All right. So before storing your data into Kafka, what we have to do here is we have to create a topic first. All right. So for example, guys, I'm kind of like I want to have all the login related information from all my source system. So basically, I can say that it is a login topic. Now, guys, what I'm doing here is, so once this topic is created, guys, I can push my data from my source system to this particular topic. In fact, all other system who wants to write your data, they can push your data into this Kafka topic. All right, they can write into this particular Kafka topic. All right, wonderful. So my data is written inside my Kafka broker in the form of topic, guys. All right. So basically, producer publishes those kind of like events or messages into this Kafka topic. Now, if these are nothing but my consumers, right? So who wants the data? They are called as consumers. So now I got producer who is producing the data, and another component we got kind of like consumer. So consumer wants to consume those messages. From where it's gonna consume the messages, guys? It needs to consume the messages from the topic. So basically, this guy will consume, it will not consume from your real system. It will connect to this Kafka broker and it will read your data from here itself. Suppose, let's say that this guy requires the same data, so he can connect to Kafka and grab this data, right? He can connect to this data and he can grab this data. And basically, let's say that if it is Hadoop, guys, I can make, once I got the data, I can process my data a technology like Hive or Pig or MapReduce or Spark or any other. If it is data stage, guys, I can perform ETL on top of this particular data. I can generate some kind of like report on some kind of like metric. All right. Now, what is the difference here, guys? Am I hampering my real systems, guys? Am I hampering my real system? No, right? I'm making only one connection here, and I'm writing all my data into my Kafka cluster. And later on, n number of consumers is kind of like consuming the same data. N number of consumers consuming same data. All right. So basically, producer publish the message, consumer is going to subscribe this particular topic, and they're going to grab your data. So that is the reason they call it as publish and subscribe model. Now, if I talk about the IOs, guys, can I say IOs is being less utilized here? I'm doing a copy, one-time copy. Yes, is this right? Super. All right, cool. So this is called pub/sub model, and we got Kafka uses this publish and subscribe model. Now let's talk about the internals of this. All right. Top level, guys, if you don't, all right, if you're seeing Kafka for the first time, all right, there are some information I want to provide. They are kind of like some key features I want to specify. So first, you can say that it is a messaging system. It's a messaging system. Right. And second point you can identify here, all right, Kafka uses distributed environment. So it's a messaging system. It follows PubSub model. All right. And it is distributed in nature or distributed file system. All right. It is scalable. One of the key feature is it's scalable. All right. So scalable means what? Scalable means what? So you might know what is scalability. Initially, I got like 4 computer guys. If I add more computer to my existing cluster guys, what is this scaling guys? This type of scaling is called horizontal scaling, or you're gonna refer this as scale out. So increasing the number of computer to the existing cluster, you can call it a scale out behavior, or you can say horizontal scaling. So basically it is highly scalable. You can add hundreds of computers and it is scale out in nature. So I can add a number of computers. And one more important thing, guys, I'm not using kind of like very expensive machines for Kafka. All right. So those are kind of like my normal machines. All right. So they are kind of like I'm using a commodity hardware. So I'm not kind of like investing much on my hardwares. All right. So since I got like distributed file system, I'm getting kind of like advantage of distributed file system. Like I'm gonna get more IOs. I'm gonna get a distributed RAM. I'm gonna get scalability. All right. The other benefits you're gonna talk about here is right. We're gonna talk about is reliability. Reliability. Right. So what is reliability, guys? Reliability, performance, or reliability, or fault tolerance mechanism. What are they? So in case, guys, if I lost any one of these Kafka servers, all right, any one of this Kafka server, I may know, I may kind of like not gonna lose kind of like everything, right? I got a concept called for fault tolerance. I got a concept called replication, guys, which we're gonna talk in today's class itself. So every computer does have IOs, guys. If I have like 100 computer and kind of like each computer produces 20 IO channels, 20 input output channels. So almost like 20 into 100, 2000 IO channels, I'm gonna get it. So that means 2000 tasks I can perform in parallel. So I'm gonna get performance. All right. I'm gonna get durability. So all my messages is gonna be persisted in a disk. All right, all my messages is gonna be persisted in a disk. So I'm gonna get a durability. So I have a ability to commit, and anybody like from the disk, anybody kind of like read my data, right? Read my data from there. So so and the most key feature, guys, why Kafka is kind of like everywhere. All right, if you go to any production environment, you can see Kafka is common. All right, reason is Kafka is fast. Kafka is fast. All right, there are multiple reasons why Kafka is fast. All right, but this is the reason. And what it's going to do here is it's going to guarantee zero downtime. So you got a very reliable architecture available. So you got a zero downtime here. Right? So if you want to understand, guys, all right, where exactly Kafka has been used, right? In a real-time cases, guys, Kafka often uses for like you're gonna use for making kind of like monitoring on top of like operational data. All right, if you want to make a quick statistic on top of operational data, all right, using some kind of like metrics, Kafka has been used. If you want to aggregate your log from various sources, guys, Kafka has been used. If you want to process my data, all right, in a real time, so we need to understand this word. In a real time, if you want to process my data, guys, all right, you have to you have to use this software. Now, let's understand about Kafka use case about this real-time streaming. So there are two types of processing, guys, right? One is NRT or real-time processing or near real-time processing, and one is historical data processing. So now if I say historical data processing, what does it mean, guys? Can I get a quick response? Historical processing. Yes. All right, if you don't know, say no, no problem. All right, I got only response from Sanket. What about others? Right. So let's understand about this. This is very important. Why we picked Kafka, guys? You need to understand like why I'm using this particular system in production. All right. Apart from kind of like messaging need, guys, there are two types of processing your data. One is historical data processing. That means like I'm storing my data offline, all right, in my RDBMS over a period of time. Let's say the last 30 days data, last 40 days data, last year data, last 5 years data, all historical data I'm storing in one place. And then on top of historical data, guys, I'm trying to process my data. On top of my historical data, I want to process my data. All right. Now, what is near real-time processing, guys? Near real-time processing is, let's say that this is nothing but your application. You are using some Amazon, shopping in Amazon. The moment you click something or you buy something, guys, a real-time event gonna be generated. All right, let's say that I made a click, show more. All right, a real-time event gonna be generated. And on top of this event, guys, all right. So on top of this event, if I want to make some processing, all right, in a real time. So I just got the data. The moment I got the data, I want to process my data. All right. So if I want to process my data, guys, you require to have tools or technology which does have a capability to process your data in a real time. So you got like options like, if you want to process your data in a streaming fashion or a real-time fashion, you got like one of the very popular option is Spark streaming. All right, it is one of the component of Spark. You got another option, guys. All right, if you want to process your data in a real time, guys, you got another option called Storm. Now, Kafka also provide. Kafka is basically for data pipeline. Now, if you want to understand the kind of like advanced Kafka. In advanced Kafka, guys, you got like one of the concept called Kafka streams, right? So which does have a capability to process this real-time event. Unlike historical data processing, guys, I'm collecting 30 days data, all right, in my Hadoop or any of my ETL system. And then once I got my 30 days data, I'm processing my data and I'm kind of like making some annual reports or quarterly reports or monthly reports. So this is kind of like quick. All right, the moment data is landed, guys, I want to process my data. So if you have NRT requirement, everybody understand what is real-time processing? Can I get a quick confirmation? Mahadevan, Kalipan, is it clear? Yes? All right, wonderful. So if I have a requirement of NRT, guys, or near real-time processing, all right, almost like out of 100 guys, 80 to 90%, you can see your Kafka cluster in your architecture. This is that popular, guys, in production, right? Anytime. So you guys work for NSE, right? So all the NSE events, like all the stock prices changes and all, guys, can I say those are nothing but a real-time events? So if I want to make quick processing on top of it, guys, do you require Spark streaming or Storm or Kafka streams? Yep. Wonderful. All right. Now we got to know about the different types of processing, guys. This is one of the use case, guys. If you want to handle or if you want to process this data, you require to have Spark streaming, but you require to have some kind of like place where you can store this particular data. So now this event, guys, I'm going to store in the form of topic, right? All right, inside my Kafka cluster. And later on, guys, Spark streaming can kind of like process this particular topic in a real time. The moment data is kind of like one of the messages is arrived, Spark streaming can be kind of like quickly act on top of it and they can work it along. So it is called near real-time processing. Now let's understand, we got to know about like Kafka purpose. And now we're going to talk about the Kafka internal components, architectural components. So still now we have seen that we got a producer. So we got a producer who wants to produce the message. Right? So we got a producer who wants to produce a message. So basically producer is what he is doing. He is publishing the message. Right? So this guy is my producer and this guy is kind of like publishing my message. So this guy has to publish message where? This guy, if this guy is nothing but your producer, this guy has to publish your message where? Can I get an answer? All right, of course, inside your Kafka cluster. Right, inside your Kafka cluster. So now let's say that my Kafka cluster got multiple brokers. So we got broker one, we got broker two. So basically Kafka comprises of multiple brokers. All right, broker four. All right, broker one, broker two, broker three, broker four. All right, so I got 4 brokers available. Now we know that, guys, if I want to write anything into my Kafka cluster, what is the first thing I have to do, guys? What is the first thing I have to do, guys? I cannot store directly my data from my producer inside my Kafka broker. So what we need to do here is we need to create a topic. Very good, Jivika. All right, so let's create, so let's say that this guy is on hand creating a topic first. All right, so this guy is creating a topic. Now, all my producer is writing my data into this particular topic. All right, so whatever categorical data information I've specified, this guy is going to write your data into a particular topic. And the top level, guys, if I want to consume this data, guys, now another guy I got, his name is consumer. He wants that particular data. So what he has to do, guys? He has to subscribe to this particular topic. So basically, once he subscribed to this particular topic, he's gonna get this data. This is how we're gonna solve a data pipeline issue. All right. Now, if my data is there in Kafka broker, guys, if I want to process my data in a real time, let's say that my requirement is, all right, so I want to give you one simple use case. Let's imagine that you have, there is a sale going on. there is a sale going on in Amazon and Flipkart, and you have added a lot of items in your cart, both Flipkart and Amazon, and you're not sure, like you are just checking or you're comparing the prices across, and you kind of like waited, like you have waited for some period of time. Now, immediately, sometime did you observe, guys? You're gonna get a quick message from Amazon that, all right, or a quick email or quick message, you're gonna get it in the UI itself, that you got like something wonderful in your cart, please your cart, otherwise you're gonna lose the discount. Or else you're gonna get some offer like, like clear your cart now, or with extra 5% discount if you use this particular coupon. Yes, did you receive this type of message? Now imagine that instead of real-time processing, if I would have done historical data processing, let's say that I would have collected my data for a week, for a month, and then I would have sent a message after processing historically, I would have sent message to my client after 30 days or 40 days. Does it make any sense, guys? Does it gonna be useful? No, right? So there are certain kind of like processing where you want to act quickly. That is nothing but a stream-based processing. So if this guy wants to make a processing, guys, or he wants to make out some data, the moment data is landed in this particular topic. So what we need to have, guys? We require to have kind of like some stream processing, right? You got like option like Spark Streaming, Kafka, and Storm. Those are nothing but options. Now, guys, all right, you got a component. You got a component, another component, which is very important with respect to architectural stuff. All right, so you got a component called Zookeeper. Now you tell me, guys, what Zookeeper is. All right, I'm not talking in terms of technology, guys. Just tell me what usually in a real life, what Zookeeper is. Come on. English, Zookeeper. What is Zookeeper? Guys, I need response. All right, if you want to grab a lot of things from this training. All right. So basically, Zookeeper is the one who is going to manage the zoo. Am I right? So can I say he's acting like a coordinator between animals and visitors? Can I say he is acting like a coordinator? All right. In case if one of my animal is not well, can I say Zookeeper will get notification? Yes, Zookeeper will know. Zookeeper will know that a particular wonderful. Absolutely, guys. So, so basically, Zookeeper in technology acts like a coordinator system, guys. So basically, it is act like a coordinator. So if you want to install Kafka, guys, you require to have a Zookeeper cluster as well. So it is acting like coordinator system. So now, all my broker is kind of like sending a heartbeat call to Zookeeper. In case if Zookeeper is not receiving any heartbeat call or any movement over a period of time, let's say that by default it is 10 seconds. All right, if by default in 10 seconds, if Zookeeper doesn't receive any heartbeat call, all right, it's going to consider that particular broker as a fail. All right, so basically this is nothing but another set of computer, and another architecture altogether. What it does, it's gonna coordinate your Kafka cluster and your consumer. All right. So now anything happens to a particular broker, if it is down or if it is not working, guys, Zookeeper will get the notification. That is the purpose of Zookeeper. We're gonna talk more about it, like how it gonna identify or how it gonna map all this broker in Zookeeper, guys. I'll show you that. Now we got to know about the overall picture. Now let's talk about each component in detail. So let's talk about a topic. So again, guys, it's very easy. Producer is going to write your data into Kafka topic. So imagine that this is nothing but your topic. All right. So this topic can be huge, right? So I cannot, sometime if this topic is going to be that huge, guys, I cannot store them inside one single computer. So your topic is going to be further divided in the form of partitions, guys. Topic is further divided in the form of partition. And every partition got a unique ID. You can call it as partition ID. So basically, this is nothing but my partition ID. So how many partitions I've drawn over here? There are 3 partitions I have drawn. There are 3 partitions I have drawn. So all my data is going to be written in this particular partition. So now one more important point we want to raise. So Kafka will not maintain offset for each your messages. So basically P0, P1, P2, these are nothing but your partition. All right. Now let's say that if I want to write my data into partition 0, all right. So the moment you write it, guys, it will maintain an offset. So basically it's going to write your first message in the 0 offset. And second message, guys, it's going to write your second messages if I want to write it in a partition 0, guys. So first message, guys, second message, I'm going to write it over here. So now the top part, guys, which I'm specifying here is to identify a message position. And we can call this component, or we can call this as offset. So now every partition does maintain its own offset. It's not 0, 1, 2, 3, then continuation. All right, every partition does have their own partition independently. All right, I'll show you like how the data is going to be distributed later part. But at this particular point of time, let's understand like how is data is being written. All right. So now my topic is going to be further divided in the form of partitions, guys. Partition maintains individual offsets. And now, guys, anytime anyone who wants to write your data, guys, anytime if they want to write your data into your partition, guys, they have to write your data in the last offset of that particular partition. So writing is going to happen this side. So if you want to add a new message, guys, it has to be in the last offset. If you want to write this message to this particular partition, guys, all right, it has to be here in this particular stuff, like this. All right. So if I want to write my data, guys, writing is going to be happen this side from the last offset of your partition. All right. And if I want to read my data, guys, definitely, guys, it has to be start from here. Reading is going to be this side. Right. So I have to read from the beginning to the end. Otherwise, if I specified a specific offset, guys, I can skip the rest of the stuff and I can start. So basically, reading gonna happen this side. Got it? So the point is, guys, topic is further divided in the form of partitions. And now, if I talk about the brokers in between, guys, can I say this partition is going to be distributed? Can I say this partition can store across like different computers? All right. And what is a Kafka cluster computer you can call, guys? Can I say this partition can be stored across like multiple broker? Is that true? Am I making sense, guys? Am I making sense? Yes, say yes, no, maybe. All right. So, so basically what we are, Saket didn't get this point. Saket, all right. So now if I want to take this, all right. So we can say that these are nothing but my Kafka cluster, right? So I cannot store my topic inside one single computer, right? So can I say my partition can be stored across multiple brokers? Can be stored across like multiple broker? Is that right? Now, does it make sense? So broker is nothing but a Kafka cluster computer. All my partition, all my topic is going to be further divided in the form of partitions, and it's going to be stored across like multiple brokers. Right? Yes, everybody is crystal clear till now? Can we get a quick confirmation, guys? I want energy, guys. All right, wonderful. So we talk about, all right, Kafka components. Now, let's talk about some more internals of Kafka architecture. All right. So let's do one thing, guys. Let's take a small break. All right. So every logical hour, guys, we're going to have a very small break. All right. A break of 10 minutes or 5 minutes. All right. So now let's take a break. Once we come back, guys, we're going to understand the rest of the stuff. Done? So once you guys come back to the class, just specify a message called back in your chat. Okay. Hey guys, I'm back. All right, hope everybody's back. All right, super. Now, one golden point you have to keep in your mind, Kafka stores your data in the form of key value pair. So Kafka stores your data in the form of key value pair. So basically, guys, if I store my data, if I want to store my data in a Kafka, it has to be in a key value format. So if you specify key and value, guys, all right. So basically for each message, guys, you're going to have key. For each message, you're going to have key. All right. So anytime if you want to store your data in a Kafka, it has to be in a key value format. All right. Now let's understand a few things here with respect to Kafka internal architecture. So now you got to know that Kafka topic is going to be divided in the form of partitions. Kafka topic is going to be divided in the form of partitions. So basically, let's say that this is nothing but one of my topic I've created. So this is nothing but my login topic. Right. Now you have to decide, all right. So how Kafka is going to decide which partition will go to which partition will go to which broker. So this is broker 1, my Kafka cluster broker 1. This is broker 2. This is broker 3. And this is broker 4. And we all know that all this Kafka cluster is kind of like managed or controlled by another coordinator software called Zookeeper. All right. So basically, I got like 3 partitions, P0, P1, and P2. Now, on what basis, guys? All right, it's going to pick a particular broker to write your data or write your partition. All right. So basically, what's going to happen if you want to go deep dive into it? The moment Kafka cluster starts, guys, the moment Kafka cluster start, all right, it's going to make one of the broker as controller. So what is controller? All right, controller got all the capacity of the, like all the features of the brokers. It can store the topics. It can kind of like you can have to read or write from your data from your broker. So basically, generally, guys, the first computer who join your Kafka cluster, guys, Kafka will elect this guy as a controller. So one of the broker in your entire cluster is going to act as a broker, act as a controller. Now this controller, guys, all right, what Zookeeper internally does, guys, it's going to create a watch list. So it knows that broker 1 is nothing but my controller. There is a specific use case like why this controller is needed. Now, what it gonna does here is, all right, let's say that my partition is being shared here. All right, now my first partition is shared over here. Second partition is shared over here. And third partition is gonna be shared over here. All right. So let's say that it has do the load balance and it has shared 3 partition across like 3 brokers. All right. Now, my question is, guys, if I lost any one of this broker, will I able to read my login topic at this particular point of time? will I able to read my login topic at this particular point of time? Say yes, no. If I lost this particular broker, will I able to make this particular topic? No, right? So partition 1 is missing, so I cannot. But at the beginning, guys, I said like Kafka is fault tolerance mechanism. It does have very reliable and zero loss and fault tolerance mechanism. So how are we going to handle these failures? All right. So in order to handle this failure, guys, you got a concept of replication, guys, in Kafka. So replication is nothing but duplicating your partition across multiple times. All right. So let's say that while creating a topic, you have specified my replication factor as 3. So if I specify my replication factor as 3, so each of my partition is going to be kind of like duplicated across your cluster 3 times. All right, each of my partition is duplicated across 3 times. All right, so let's say that partition 0 is duplicated 3 times. Partition 1 is duplicating 3 times. Partition 2 is duplicating. Partition 3 is duplicating 3 times across my cluster. All right. Now, in case, guys, if I lost this particular computer, am I gonna lose everything? No, right? So I got a copy available for partition 0 and 1 and 2. If this particular computer dies, no problem. I got other broker who is serving my same partition. That is how you're gonna get a fault tolerance mechanism. Now, if I talk more in detail, so this guy is writing a topic. All right. Each topic is further divided in the form of partition. All right. Now, this partition, guys, this partition, all right, if I specify replication factor as 3, replication factor as 3, guys, what's going to happen, guys? So this partition is going to be duplicated 3 times. This partition, P0, second replica, P0, third replica, I'm going to get. All right, 3 replicas I'm going to get. Right. So now out of which, guys, one of the partition, guys, one of the partition will become or will, all right, they're going to make an election and one of the partition becomes a leader partition. So let's say that my Kafka make this particular partition as a leader partition. All right. And rest of the guys, I got like, these are the nothing but my followers. All right. Or else I'm going to give a new technological name called in-sync replica, ISR, in-sync replica also I can call. Now, if my producer or consumer wants to read your data, so suppose this is a producer, definitely he has to read your data from a particular topic, right? So if he wants to read your data, he has to read your data from leader partition. Read or write is going to be done with the help of leader partition. Let's say that you have written something in partition 0. Now the responsibility of leader partition is, guys, to make updates. So basically leader has to replicate what are the changes across your followers or across your ISR, so in sync replicas. All right. So if you want to read, guys, every time you have to read your data from your leader partition. Every time you have to read your data from leader partition, and followers are kind of like replicate the data from the leaders. Is it crystal clear, everyone? So this is very important, guys. Now, come back to the previous screen. All right. Now we talk about the controllers, right? So one of the computer is elected as controller, all right? So this controller does have a capability to elect for a partition. It does have a capability to elect a leader. So since this particular broker is controller, this guy does have a ability to elect. So basically partition 0 leader is over here, partition 1 leader is over here, partition 2 leader is over here. So every time, guys, if you want to read your data, so this guy controller is going to elect your leader. You can read your data from partition leader. Now, in case, guys, if I lost any particular broker which does have a leader, guys, now what Kafka does, guys, any one of the available ISR, let's say that this is P0, P0. And these are nothing but my ISR in sync replica. So what it's going to do here is, if I lost this broker 1, this available ISR, guys, in sync replica, guys, it's going to elect as a new leader. Now, if this guy come back again, guys, if this guy come back again, broker 1 come back again, now this guy will join as ISR or follower. Got to know? So we got to know about partitions, how your data is going to be written in partition, how data is going to be written in partition. We got to know about the controller, and we know about, like, we got a leader partition, and rest of the stuff are ISR in sync replicas. Now, another important point you need to know, all right, how Kafka stores data in which format. So Kafka stores your data in serialized file format. Kafka doesn't care about the format, by the way. So basically, if you're writing your data in a Kafka, all right, Kafka doesn't care your data format. Whatever data you're gonna write it, guys, it's gonna write or convert them into serialized file format. So what is serialized file format? If I ask this question to you guys, what is serialized file format? Yes, guys, I need answers. All right. So what is serialization, guys? You have learned Java, right? What is serialization? Imagine that. Guys, if you don't know answer, say no. We don't know answer. Not a problem. So this guy wants to write a file called pawan.txt. Can I say pawan.txt does have like human readable format? So I got like CSV file. Some CSV file I have in this particular text. Now, guys, if I want to send this data across a network, guys, what is the only language my network will understand? What is the only language my network will understand? All right, my network will understand my only one language called 1 and 0, 0, 1, 1, 0. All right, basically. So what is this process called, guys? Converting this object stream data to a byte stream data. What is this process called, guys? This process is called serialization. All right. So now Kafka, whatever the data format you have, let's say that you got like text file, you got JSON file, you got some XYZ file, you got a TSV file, whatever format, Kafka doesn't care about the format. It can store your data in a serialized file format. So anytime, guys, if I want to store this pawan.txt into my Kafka, guys, do I need to serialize my data, guys? So if producer wants to write your data into Kafka topic, guys, so my producer has to serialize my data. All right, so that like I'm gonna get it 10101010. Wonderful. This is very important point. Now, On other hand, guys, if consumer wants to read the data, can I consume 101010 file? Right. Will it make sense, guys, if I want to read this particular data? No, right? So if I want to read this particular data, guys, do you think I require to deserialize my data? Deserialize my data so that I can read my pawan.txt back. All right. Wonderful, guys. So this point you have to keep in your mind, guys. All right. Kafka stores your data in a serialized file format, in a very low level machine specific format. What is the reason, guys? Right. I don't need to worry about too much about the formats. Secondary thing, guys, if you serialize your data, it's going to compact your data, or it's going to compress your data much more than your text file or any other file format. So it's going to occupy less space. So less space and less throughput is required, guys, if you want to capture this data. So it makes things kind of like fast. Did we get this? Can I get a quick confirmation? Yes, super. All right. Now we got the top level architecture, guys. All right. So one more important thing I want to teach you here. This is very important, guys, with respect to Kafka. Now, we know the fact, again, I'm writing, guys, to make things clear. We know the fact, all right, if I write my data into, if I want to write my data into topic, guys, all right, in the background, guys, I have to write my data into a particular partitions. So basically, I got like partition 0, partition 1, and partition 2. Right. Imagine that I got 3 partitions I've specified when I want to create my partition. So now if you observe, guys, this is nothing but my partition 0. This is nothing but my partition 1. This is nothing but my partition 2. Now, if a new message arrives, so which partition I have to write my data? All right, which partition I have to write my data? I got like 3 independent partitions running, 3 independent partitions running. All right, and if you observe, guys, each partition does have its own offset stuff. So every offset starts with 0. Now this message goes to partition 0 or partition 1 or partition 2. How are you going to decide it? All right, let's understand the internal about this. So we know the fact that Kafka stores your data in the form of key value pair. All right. Now, if you don't specify this key, or if you make your key as a null, all right, then your message distribution is going to be round robin fashion. So imagine that after message 1, guys, this guy is kind of like receiving message 2, message 3, message 4, message 5, message 6, message 7. All right, these are the kind of like messages it has to write inside your Kafka. Now, which partition it has to write? Now, the question is, now the first scenario is, if you don't specify any key, guys, what's going to happen? It's going to store your data in a round robin fashion. Round robin fashion. What is round robin fashion? So now the first partition is going to pick randomly. So it's going to write your message 1 over here in my first offset. All right. Now the second message, guys, it's going to write in second partition. Third message, it's going to write in third partition. Same way, guys, in my second offset, guys, it's going to write my message 4. All right. So basically, it's going to share 1, 1, 1, and then it's going to share over here, and then it's going to share over here. All right, wonderful. Like that, your messages is gonna be written. All right. So can I say partitions 0, second offset, I got my 7th message, right? Wonderful. All right, this is one of the use case, guys. If I don't specify any key, key is all your messages is going to be stored in a round robin fashion across like each partition, so they can do the load balance. So this type of stuff, guys, I can use, guys, where I don't require any message order. So I don't require any message order. I am okay. I can partition my messages over anywhere across my partition. Now there is another use case. There's another use case, guys, where I want to send all my, all right, so Pawan has done some transaction. So Pawan has done a transaction of 20 USD. All right, Pawan has done a transaction of 50 USD. Pawan has done the transaction, all right, 25 USD. All right, Pawan has done the transaction of 120 USD. Now we got all right. So let's say that we got Jivika. So Jivika does all right, did a transaction of 20 USD. All right, Jivika has done transaction of 10 USD. All right. Now let's say that we got Sanket. Sanket has done transaction of $8. All right. Sanket has done all right, 5 USD, right? And let's say that Kaliappan has done, all right, or let's include this 3 only. All right, we're going to talk about later. So basically, guys, what my requirement is, guys, all right, I want to process all my Pawan partition in one partition. All right, so I want to make sure that all my Pawan data has to go, or my Pawan related transaction has to go to a particular partition. It can be a partition 0, partition 1, partition 2, I'm not worried. But I want to keep my data all right, in the order, all right, in the same order, in the same order, guys. I cannot have kind of like Pawan key all over here in my partition. All right, I cannot have this Pawan messages. So if I do round robin, guys, so imagine that this is nothing but message 1, this will go to partition 0. Imagine that this is message 2, this will go to another partition. Message 3, this will go to another partition. If I have 3 partition, then message 4, it will go to first partition. Like that, it's gonna do. Now my requirement is, guys, all right, whatever, like, whatever kind of like all my Pawan key has to go to a particular partition. So in this case, guys, you require to specify a key, all right? You need to specify key as what type of data you want to put in a single partition, all right? So basically, I'm going to internally use a hash partition. Based upon the hashing of the key, guys, I'm going to allocate a partition. So now imagine that I got like 3 partitions which I want to store my data. So my topic is divided into 3 partitions, partition 1, partition 2, and partition 3. All right. Now, so since I got like 3 different key, my hash partition will decide, right? Hash partition will decide which key will go to what partition, right? So it can pick one of the partition for Pawan, one of the partition for Jivika, So let's say that partition 0 is assigned to Jivika, partition 1 is assigned to Pawan, all right, partition 2 is assigned to Sanket. Now the first thing, guys, so I got my Pawan message. So this is nothing but my message 1. So what my hash partition does here is all the Pawan related keys. So basically, if you want to arrange your data in an order of the partition with the same key, guys, you require to specify a key. Require to specify a key and value. Super. So I require to specify a key and value. So here I'm going to specify my key. On basis of my key, guys, I want to partition my data, right? So let's say that my key is my name. All right. Now let's say that the first message where it's going to write, guys, since it has assigned all my Pawan key to this particular partition, guys, it's going to write your message here. So key is Pawan, value is 20 USD. All right. So in my 0 offset. All right. Second message is also Pawan. Second message is also Pawan. So it's going to write over here, Pawan. Third message is also Pawan. It's going to write it over here, Pawan. All right. Fourth message is also Pawan. It's going to write it over here, Pawan. All right. Now the Jivika. All right. So this 1, 2, 3, 4, fifth message is of Jivika. So it has assigned Jivika for this particular partition. All right. Let's say that Jivika got like message 5. So Jivika key and 20 USD dollar, right? In the 0 offset and in the first offset, guys, I got like Jivika 10 USD. Same way, guys, I got like Sanket this too. Now let's say that I got now again a Jivika message, I got it. So if I get a Jivika message, guys, it's going to write into this particular partition. So, all right, it's going to write Jivika partition. Now another scenario, guys. I got 3 keys, 3 partitions. So everybody got kind of like one partition for their keys. Now let's say that I've included Kaliappan key, 2 USD dollar he has spent. So now, guys, and let's say that I got like few more. I got Nazreen key as well, right? 3 USD. Right. Now I got like 5 different keys, 5 different types of keys, and I got 3 partitions. So basically, a partition will arrange 2 of the partitions. Like so, in future, guys, it's gonna send Kaliappan key also to this particular partition 0. And let's say that for partition 2, it has assigned Nazreen keys as well. So now the moment Kaliappan keys goes, it's going to be added here. Kaliappan keys, all the Kaliappan keys will go over here. And all the Jivika keys will be written over here. Same way, all my Nazreen and Sanket keys will written over here. This is how internally Kafka stores your data. Right? So you got a fair idea on like how Kafka stores your data, right? And how your partition is kind of like distributed, how messages is going to be written in the partition, top level. All right. Super. Now let's understand, based upon whatever we have learned, let's understand about some configurations, guys. So basically, guys, you got like 2 types of configurations. All right. If you want to write your data into a Kafka cluster, guys, you require to know producer configuration. And if you want to read your data from Kafka cluster, guys, you require to know about the consumer configuration. So while coding, guys, you require to know, or basically, guys, if you want to connect using client like Node.js, or if you want to connect using Java, you require to know about this producer and consumer configuration. And this producer and consumer configuration will help you to kind of like control the behavior of producers and consumers. All right, here, with the help of this configuration, guys, I can grab the optimizations as well. Now let's talk about some of the configuration, guys. If you want to know about any configuration, guys, blindly log into, all right, just type Kafka producer configuration, and it's going to take you to site of Confluent. Confluent is nothing but one of the company which supports, which gives paid version of Kafka, you can say, or which supports Kafka. So you can take a support from Confluent. So I got like one of the property called producer configuration. So generally Kafka is an open source. All right. Kafka is nothing but an open source software. So you don't need to pay anything for license. Anyone can download and anyone can modify the source code as well. Now, if you want to have a support from a professional support, guys, you can have kind of like support from the Confluent team. And they have provided kind of like more kind of like APIs on top of existing Kafka. All right. So these are kind of like common in Kafka. Just make a note of it. What are these properties are? So guys, one question I want to ask. If I want to send my data into Kafka, what format it has to be? Yes, Sanket, Kaliappan, Chivika, Mahadevan. What format it has to be? Byte stream. What we can call? Can I say serialized file format? Yes. So it has to be a serialized key value format. So anytime, guys, if I want to send my data into Kafka, it has to be a key value format and it has to be serialized format. So guys, if I want to send my data to Kafka, do I need to serialize my data, guys, key and value? So producer, if producer wants to write your data, all agreed with this particular point? Wonderful. Now, same thing, guys, for consumer, guys, if you want to read or write your data, guys, do you think what you need to do? What you need to do? What you need to do, guys? I need a response. So if you want to read my data, so you have to deserialize. Absolutely. All right. Now I got few properties, very important properties called acts. All right. So basically, guys, in order to understand this acts, I have to draw a die. All right. So acts is equal to 0. Acts is equal to 1. Acts is equal to all. What does that mean? All right. Acts stands for acknowledgement. All right. Now, in order to talk about the acknowledgement, guys, you need to know about like synchronous and asynchronous. Synchronous and asynchronous. Asynchronous. So guys, what is difference between synchronous and asynchronous, guys? What is the difference between synchronous and asynchronous? Anybody? Anybody, guys? Yes.
Synchronous is where it happens in sequence and yeah, it is dependent on each other and it happens step by step. Asynchronous is where it is can be done parallel or
Okay, you're almost correct. So basically, if I want to define synchronous, so let's say that I am writing my data in some place. So I have written my data. All right. Once my data is written, guys, all right, I'm going to get an acknowledgement from my system, or let's say that from my Kafka or any other system. So I'm going to get an acknowledgement, right? So once I get acknowledgement, guys, then I'm going to take up the next work and I'm going to write the next thing. Then I'm going to get acknowledgement. This is nothing but a synchronous. All right. So basically, as Jivika say, it is sequentially, we are trying to writing our stuff. Now, on other hand, if I talk about asynchronous, right, asynchronous, all right, I got like multiple piece of work. And now guys, all right, I am writing my data, all right, and I'm not worried about the acknowledgement, whether this particular data has been written or read or written. I can write my another data without worrying about whether this particular data has been written or read or written. All right, all right, wonderful. So if I'm not worrying about the acknowledgement, guys, can I call it is an asynchronous server? Right? Whether this data is successfully written or not in my source system, if I don't get any acknowledgement, guys, those are nothing but asynchronous way. All right. Here I can do things in kind of like parallel without worrying about the acknowledgement. Now, x is equal to 0. All right. Very important concept. So if you observe, if I want to write a partition, guys, how many partition I have to write, guys? So let's say that I got one partition, guys. All right, if I have one partition in my cluster, guys, how many partition I have to write? How many partitions I have to write? All right, you have to say Pawan is depend upon replication factor. So if I specify replication factor as 3, all right, so I'm gonna get kind of like 3 replicas. Wonderful. Now, if you know that, like if I want to write my data, which particular system I have to write, guys? Can I say from our discussion, guys, can I say I have to write my data to a leader partition? I have to write my data to a leader partition. So now let's say that I made a write request over here. And later on, my leader has to replicate my data across my ISRs, all right, across my followers. All right. So if I specify x is equal to 0 in the configuration, guys, all right. So I'm going to initiate this write stuff. I'm going to initiate this write stuff. All right. So guys, if I specify x is equal to 0, all right, it is kind of like asynchronous server or asynchronous response. So it's gonna make a write request and it will not wait for any acknowledgement. So if this particular data is not been written, guys, I make kind of like chances that my data is going to be kind of like lost. Now, if I specify a x is equal to 1 as a configuration, guys, this guy will write your complete data into a leader partition and it will get an acknowledgement. It will get an acknowledgement over here, all right, that I have written my data successfully to a leader partition. All right, and but it will not worried about like ISR, whether they are replicated or not. All right, but it will take acknowledgement 1. So at least one kind of like leader partition is written successfully. I'm not sure about whether the other followers has been kind of like written or not. Now, if I specify access all guys, what it does, guys, you know, it has to wait for the acknowledgement from this followers, this follower, and this follower, and then it's going to take up another work. Now, make sense? All right. About this property. Super. So we got x0, x1, and x all. Now, guys, if I want to connect any Kafka cluster, guys, I don't need to specify all my brokers. All right, all my brokers, I don't need to specify. All right, so suppose if I got like hundreds of brokers available, in my case, I got like 3 brokers available. So all my brokers is kind of like registered in Zookeeper, all right, in one of the node, All right, inside a directory called broker under IDs. So basically, if you want to know low level, like how Zookeeper will register a fault tolerance mechanism. So broker underscore IDs in Zookeeper, it's gonna make, okay. So this one is nothing but broker one. All right, broker ID is this. This one is broker ID is 2. So 2 is alive, right? 3 is alive, right? It's gonna make a list. How it good to know? Because each Zookeeper will send a heartbeat call to this particular guy. Now, guys, in a real time, if you want to connect to any of your Kafka cluster, you don't need to specify entire kind of like this IP address of this, IP address of this, IP address of this. I can specify any one of this particular broker to connect. So I'm going to connect to one broker, and what it's going to do here is it's going to allow me, since with the help of Zookeeper, Zookeeper does have a list of all this broker which is mapped in my cluster. I can access my entire cluster. So basically, Bootstrap server is nothing but any one of the, or any few of the Kafka broker. I can specify one. Safer side, I can specify 2 broker IP addresses to connect to particular cluster. So that is nothing but Bootstrap server is nothing but Kafka broker address. All right. So host comma local, or so IP address comma port. So this I can specify IP colon port 9092. All right, my production IP colon 9093. All right, I can specify this as a bootstrap, and I can connect to entire Kafka cluster. So I need to specify over here. Now I got few more properties like buffer memory, guys. So while writing your data or reading your data, guys, all right, Kafka will not store your entire message at one go. So basically, it's gonna push your data in the buffer. All right, push your data in the buffer. And once the buffer is full, guys, and it's gonna kind of like flush your data in the Kafka broker. Same way, guys, if consumer wants to read, guys, they can use the same buffer memory, and they can consume the messages from there. All right. Wonderful. So we need to learn few more properties, guys, few more important properties, guys, which I'm going to show you in next class, right? And then we're going to talk about more producer and consumer properties, and then we're going to jump it into API section. All right, in the API section, guys, we're going to access things from our Java and Node.js applications. And once it is done, guys, we're going to talk about failures. We're going to talk about performance tuning. We're going to talk about a few topics. All right. So that's it from my side today. If you have any questions, yes, you can ask. Hope everybody able to follow session. Yes. Right.
Pavan, just one question. When we put a message with key and this one, the values, the decision of which partition it goes to is managed always by Kafka, is it?
No, it's managed by one of the algorithm called hash partition.
Yeah, I mean, what I'm asking is from the code, you will not be able to manage, like it has to go into this partition.
No, from the code also we can manage. We have to write a custom partition. I can specify, let's say that you got a requirement that all Asia keys and all the US market related stuff has to go to a particular partition. Then I can specify, all right, I want to send US key to a particular partition, and the India key has to go to another partition. I can specify, I can control this behavior by writing a custom partition.
Okay. And say if so we have multiple keys and one particular key, and say I don't mention the partition, so it will assign partition based on the logic. And if one particular partition is, I'm sorry, one particular key has more values, it will be saved in that particular partition only. It will never be across partitions when we mention the key.
Absolutely. If it by default it's going to take hash partition. So hash partition, there might be a chances that you're gonna have like a key which got like more values. All right.
That's what it is, yeah.
So then like hash partition will not work. You have to write your custom partition and you have to redistribute your partition. Manually, you have to specify like this particular portion of data, I want to send it over here. This particular portion of data, I want to send it over to second partition. And rest of the data, you can do the hash partition also.
Okay. And for the acknowledgement, if we mention it as acknowledgement 1, so the writing is in, so it makes sure that it is in sequence, right? That is the first message. Only after it gets completed, the second gets put, and
Yes.
so forth.
In Kafka,
Hmm.
in Kafka, all right, in Kafka, all your read and write request goes to leader partition. So anybody will write into a leader or read your leader or read from the leader, and later on it's going to replicate the changes data across your in-sync replicas or follower replicas. So if I don't specify acts of 0, if I specify don't care to take acknowledgement. If I specify acts of 1, it's going to take care, at least like leader has to be written successfully. Then, all right, I can move to another message. But if I specify acts of all, it has to write it into a leader. Wait till all the followers got the data, and then it's going to send an acknowledgement to client.
Yeah. Okay. For me to make sure that I have written them, I'm rewriting the messages in the same sequence and reading it in the same sequence. So so it has to be X1 at least, right?
X1, yeah.
X all will make sure that I'm not having any data loss for some
But
reason.
yeah, data loss will not be there. But like at the same time, guys, it will take your latency.
Latency will have a hit. Yeah.
Yeah.
But if leaving aside latency, if I have to maintain the sequence,
minimum you need to make an X of 1 for sure. All right. If you want to have like optimal value, minimum you have to have X of 1. If you want to maintain kind of like prevent the data losses and all.
Okay. Okay. Thank you.
Okay. All right, guys. See you. Oh, you got holiday tomorrow, right? So we're gonna meet on Monday. All right, and we're gonna do a few more important configuration, and then we're gonna jump it into the coding part. So in the coding part also, we require to have some configuration. Those important configuration I'm covering before, and then we're gonna code, like work out with Kafka producers, Kafka consumers. If time permits, we will learn like how to write a partition, how to write a custom partitions, as Jivika asked. All right, and later on, guys, we're going to talk about the important aspect of performance tuning and all. So that's it from my side. All right, all the best. See you soon. Bye-bye.
Thank you. Bye.
Bye-bye. Welcome, guys.